Suppose we start with a Hershey's Kiss, which is shown here, larger than life size. And we think about this as a solid, and we want to figure out what is the volume of this thing. Well, we can actually do that with a couple calculations. So first of all, let's take our Hershey's Kiss and rotate it so that it looks like that. Then what we're going to do is we're going to think about sitting this on the coordinate plane and fitting a function to it. So here's the function that we end up with, and you can see it's pretty close to the outline of the Hershey Kiss. And we now have a function that if we rotate it around the x-axis will generate a solid that has the same shape as a Hershey's Kiss, approximately. So as we've done in the past, we think about, well, what happens if we make some sums and think about, okay, so we're approximating the area under the curve here with these Riemann rectangles, and we can get a better and better approximation as we increase the number of disks. Well, or number of rectangles. What we're going to do is we're going to rotate each of these rectangles then around the x-axis to form a cylinder. And that gives us this figure over here. And you can see we have a whole bunch of disks or cylinders, 12 in fact. And each one of them has a height equal to the height of this rectangle, which would be, in other words, it's a left Riemann sum, so it gives us the height of the rectangle at the beginning of the interval. And the width of each of these cylinders, or kind of the height if you think about the cylinder stacked vertically, that's just equal to the interval width here. And so again, as we move this closer and closer, the number of disks, as we increase it, we're going to get a better and better measure of the volume of this Hershey's Kiss. And you can see what we end up with here is we have these sums where we would say, all right, let's go back here where we have just 5 disks. And the height of this first rectangle is equal to 3. So the volume of this first disk is then equal to pi times 3 squared, which is the surface area of the base, multiplied by the interval width, which in this case is 1.64. Then we move on to the next rectangle, which creates the second disk here, which now has a height or a radius, if we want to think of the cylinder, of 4.29, so pi times 4.29 squared times the same width for the cylinder, or height again, 1.64. And so we just sum the volumes of each of these and we will get the total volume of this figure when it's been rotated around the x-axis. And again, as we increase, we're going to get a better and better approximation of what this thing looks like. So another way of thinking about this is that we took our function and we just rotated it around, and as it moved around 360 degrees, it formed this figure here, which basically has the shape of a Hershey's Kiss.